Okay, find the area under that graph between 0 and x. Okay, so we want to go with the substitution again. U equals 1 minus t squared. So that means du du equals minus 2t dt. So the integration becomes minus 1 over 2. Integrate minus 2t over 1 minus t squared a dt. So that is minus a half. Integrate du over u power a. So that is minus a half. Increase the power by 1. So that's minus a plus 1 over minus a plus 1. So that would be 1 over 2 a minus 1. And then again, I think we want to say 1 minus a. So that would be a minus 1 in the power in the denominator. 1 minus t squared. 0 to x. So that would be 1 over 2 a minus 1, 1 over 1 minus x squared, a minus 1, minus 1. And again, I think this should say a is more than 1. And then when x goes to 1, oh, maybe this case here, 1 minus x squared, 1 minus a. Yeah. Yeah. I think a is more than 0, but I think do we have to say a is less than 1 here? Because or does it not matter? We just don't want to divide by 0, so we don't want a negative power. So we want to keep 1 minus a positive. So if we say that, then we'll get, then this will become 0. So it becomes 1 over 2, 1 minus a, which I could possibly check. Yeah, if a is less than 1, and the limit diverges if a is more than 1. Okay, so I guess I opened the ticket for the previous one, but I guess they would want you to say about the answer having to converge or diverge. So yeah, we have to have a less than 1, otherwise it's divergent, and there isn't isn't an answer. Okay, so that's okay. That's okay. Now that's that one done. 316. The area of the semicircle radius 1 can be expressed like that. Use the substitution to express the area as an integral of a trig function. You do not need to compute the integral. Okay, so that means dx dt is minus sine t. So dx is minus sine t dt. So the integration becomes root 1 minus cos squared t. Because we said x is cos t. Dx and dx is minus sine t dt. So this becomes root, and that's sine squared, so that's sine, but this one has to be a positive technically, times minus sine t dt. So we just got to be careful with the limits. When t is minus, no, when x is -1, the t will be pi, and when it's 1, it'd be 0. So that would be pi to 0, or 0 to pi, and then we get to flip the sign, sine t and sine t. But the good news is sine t is positive between 0 and pi, so we can drop the modulus. So it just becomes sine t dt. So it just becomes 0 to pi sine squared t dt. Okay, 317. The area of the top half of an ellipse can be written like this. Use that substitution to express this term as an integral. You do not need to compute. Okay, so if x equals a cos t, then that means dx equals minus a sine t dt. So the integration would become b root 1 minus x squared, which is a squared cos squared t over a squared dx, which is minus a sine t dt. Those a squareds cancel. 1 minus cos squared is sine squared. Root of sine squared is sine. So I think I can see what's going to happen again with the limits. So to get minus a first, for x, this would have to be -1, which would be pi. And then to get a, I should write it the other way around to keep it lined up. To get minus a, this would have to be pi. And to get a, this would have to be 0. So it'd be pi to 0, which would be 0 to pi. And I can flip the sign. That's AB. Sine t dt. And again, sine t is positive in this domain. So it's AB, 0 to pi, sine squared t dt. I feel like there's a little mistake somewhere. Maybe? No. Maybe not. Oh, I can check the answer for that one. AB sine squared t. Yeah, 0 to pi. Yeah, okay, that one's right.